Okay, today I'm going to talk on throughput. Whenever we are discussing as a senior engineer with a teammate or as an architect discussing with a teammate, and many places say, "Hey, here our API, our system throughput could be this." So many documents. If you read the highly high HLD high level design documents or low level design document. Many places we have to measure throughput. Sometimes customer also ask, hey, what is the throughput of your system? Okay, so let's understand this the concept of throughputs, and so that we should as a software engineering, our responsibility, what are the terms and terminologies used in the system designs or the software engineering, at least we should aware behind the concept, behind the thoughts, right? So here, throughput refer the rate, you can see, at which system process and complete the task or transaction or request. That means throughput means the rate at which your system can complete any task or any process or any transactions. So what the rate? Throughput means rate. It's measure the quantity of work that a system can handle within a given time frame. So let's simple understanding. We have a one person, and I have a, let's see, they have to maybe what uh, count the number of files, count the number of files or number of logs in a 5 minute. Okay? So we have given, hey person, you have a 5 minute times, and now you're going to go count the number of logs here. So the rate is the number of logs is counted, or the number of tasks is completed within a given time frame. This is the very important, the time frame. So maybe 1 hour, 1 minute, 1 second, 1 day. So what the number of tasks as a you complete. Similarly, from a system perspective, hey, my system, what is the rate at which they are completed a task? Let's say I given a task one, task two, task three, task four. The objective is not task. The one task is done by how many number of second or minute. Now rate means now our system in 1 hour how many number of tasks can completed. That is the rate. So generally rates are expressed in a particular unit. Maybe you can say, hey, RPS, request per second, maybe or transaction per minute or job per hour. So here time frame can be minute, can be second, can be hour, can be day. Okay, so maybe the 1 day, what number of tasks my system can process. So that is the rate we can calculate. The number of tasks are divided by the time frame which you are decided. So throughput is nothing the rate at which your system can complete the request or task or transaction. These are some basic terminology we should aware, like understanding the throughput. The sometime you know see the processing time. So whenever you are sending one request, our system can process the request. So processing time, a time take to time it take for the system to process a single task, a single request. Processing time is one request, how much times our system take. That is the processing times. So what is the throughput rate? Throughput rate, that means a rate at which the system process tasks or request with the given time frame. So maybe a request per hour, per minute, per second, right? So this is the throughput is the rate. A processing times is the time that your system take to complete one task. That is processing time. Okay, a throughput means now our system is capable to 1 second, might be it can serve 10 requests or 100 requests or 1000 requests, right? So this is my throughput of my system. Okay, so because a different point of view. So here's throughput in the terms of your system can perform on a given period of time. So it is possible that my system in 1 second can serve 100 requests. If within 100, within a second, if my system is able to complete 100 requests, you can say this is my rate. So throughput is the rate. A processing time is just for the completion time of a single task, single request, a single process. And something bottlenecks. So the component or resources in the system that limit the overall throughput, often the insufficient capacity or high processing time. So many times our throughput can be impacted with some bottleneck. Bottleneck might be component resources in the system that limit the processing. So many times you talk about the utilization. What utilization? The percentage of times a system or resources is busy to doing works. Okay, so our objective, whatever the resources we are using, we can utilize our resources as possible, right? So let's say we have our CPU, and hey, I given one task, they can quickly done, and after some taken again give another task, they quickly done. So our CPU is sometime become idle, not so, it is a free. They have not any task to complete. So you can say utilization is whatever the system resources you have. That is our objective. We have to utilize our CPU capability. Now our CPU, that is our person, have lots of capability, but we are not utilizing them. So the objective of throughput is that we have to send, hey, my system, we can give the multiple requests so that we can utilize our resources. So throughput, you can say also, sometime if your system is not utilized properly, might be our throughput can hamper. Our system have a capability, but we are not utilizing properly. Many times about the queuing theory. The study of waiting lines are the queue which help to analyze and predict the behavior of system under the varying workload. So many times our if our system is heavily utilized, so whatever request come, that's go in the queue, that's go in the queue, that's go in the queue. Might be we can prepare the queue of tasks so that our CPU can complete one work. Okay, take next work, take next work, take next work, take next work. So maybe the queuing jobs can make better utilizations of resources, right? And let's example with understand. So let's example we have a web server, and web server receive 100 requests per second. So requests per second. This is my web server, and they are receiving a request 100 requests per second. So that means if let's assume if take 0.1 second to process each request, that means our throughput is the 100 RPS. Right now, so if the server processing time, let's see, is processing time, it's increased, maybe you can, one request is previously served by the point 1 second, and now our single request can be, let's say, served by the point 2 second. Okay, that means our throughput now going to decrease, because now our throughput is the 50 RPS, right? Because we have a 100 requests, our requests come in a per second. So now per second, we can only serve the 50 within a second. So you can say throughput is the measure with respect to the rate of the times. So always ensure that if one task, one processing times, if processing time to going to increase, if processing time to going increase, that means our throughput going to decrease. If our processing time going to increase, that means our throughput going to rate. If my processing time going to down, that means our throughput going to increase. So we have to also ensure that if you want to increase my throughput, that means whatever the processing times of the single request, we have to going to reduce them. Let's another example in the concept database. So let's we have a database, and database process 500 transactions per minute. Let's assume by a very popular e-commerce application. So if the database processing times is the zero point 0.1 second, right? Due to that, you can say 500 transaction per minute. You can say. So what happened if database processing time going to increase? Now, if processing time to going to increase 0.2 second, then our transaction per second throughput going to decrease to 250 transaction per minute. So whenever individual processing times of the particular task is going to increase, that means our throughput going to decrease. So same maybe different lines. These are the very throughput is a common terminology used in a different industry, not only software industry, maybe in the manufacturing industry. Similarly, let's see one manufacturing lines, maybe company or factory, are producing 100 units per hour. In 1 hour, a particular factory can make 100 units of particular products. 100 units, okay, in 1 hour. That means ki our each unit one product take a zero point 0.5 hour to complete this product. Okay, so what happen if our product one product are going to increase 1 hour? That means surely we cannot within an hour we cannot complete the 100 unit per hours. So we can say somehow we have to measure the processing times help us, and also to utilize our resources. We talk about the throughput. Generally, throughput majorly help us to ensure that whatever my resources, CPU, memory, everything can be highly utilized. If we talk about the only processing time, that means maybe one request come, we are very fast process, but next request come later. Next request come later. So if my one request, our processing time is very high, that's good, but it is not meaning our system is very efficiently utilized. Until we talk about the throughput, hey, let's what is the throughput of my system within a second, within a minute, within 100. So throughput means we are going to utilize our system second wise, hour wise, minute wise. So you can say some key points from here. Uh, Throughput is measure the system processing capacity and efficiency. Right now, how our system efficiently utilize. So throughput is not just talk about the uh, rate, but the objective I throughput that whatever the my system, what the capacity and efficiency we are going to the measure. And throughput is affected by the maybe processing time, bottleneck resources, and utilization. This throughput can be affected if a processing time going to increase, or some bottleneck resources are not utilized, or maybe some utilized system resources are not properly utilized. So in this scenario, throughput can be impacted. And similarly, if our increasing the processing time, that's the reduce the available resources, that means we can decrease our throughput as well as. Similarly, if throughput is not the same as a latency, so many places whenever we system design is sometimes talk our system would be very low latency. Low latency are the response time, you can see. So here response times are latency is the although they are related to the performance of system, but latency refer the time that take from a system to respond on a request. Whenever users start one request, once reach the server and server do processing and server back response. Okay, so how much times complete from system, from user perspective, I start one sending request and what the time I respond. So complete delay of the response known as a latency here. So this is for the one specific request. You can say, hey, this is my latency for the user perspective. This each and every user can get quickly response as quick as far. That means your system is the very low latency. But here throughput is the measure your capacity, your system effective utilizations. So optimizing throughput often involves identifying and addressing the bottleneck, improving the processing efficiency, and increasing the resources. So these are some concepts. If we really want to increase our system capacity and efficiency, then we have to work on the our processing time can be improved, and whatever the resources we have, we can properly utilize our resources. So these are the some factors which also you can say impact throughput. So we have to aware right now. Whatever the resources we have, resource capacity, maybe the amount of CPU you have, amount of memory you have, IO available to the process stuff. Whenever one request come, our system going to the process. For processing, they require the CPU, they require memory, they require IO to process those requests. Let's say CPU is busy, memory is less, IO is not available. So processing time going to increase. If processing time going to increase, that means our throughput is going to affect it. Similarly, whatever the processing efficiency, the speed and efficiency with which tasks are processed. Our objective, whatever the independent individual task we receive, as speed, as quickly our system can process and complete. And so throughput also can affect about the queuing or due to the waiting. The time is spent to wait for the resources processing which can reduce the throughput. Let's keep one request come. Our CPU is busy. Our CPU, our task is going in the waiting queue. Another request come, but our CPU is still not free. So if you have a CPU is not free, or maybe some memory is not available, some IO operation is not available, so surely our tasks are going to the waiting and a queue stage. So that will overall reduce my system capacity and throughput. And sometimes also we talk about the task size and complexity. The longer and more complex take, if you are going to do processing, that will take a larger times, or if they can highly utilize my resources. So it will also affect our throughput. Okay, and if we properly utilize maybe concurrency or parallelism, so ability to process multiple tasks simultaneously can increase my throughput. So one way, if possible, let's see your task can be possible to completed with the help of concurrency or parallelism. If possible, let's do this. Will utilize your system resources, and this is also increase our overall system efficiency and the throughput. Okay, so this is one of the core, you can say, nowadays concept of the system increasing throughput about the concurrency and parallelism. But concurrency and parallelism also have some kind of a limitations. We should aware about that, I realize. This is the basic simple calculation and formula if you want to calculate how to calculate throughput. Whatever the number of tasks we have, whatever the number, let's see, 100 tasks, yeah, 200 tasks, 1,000 tasks you want to process, and the time frame, hey, within a 1 second, yeah, within a minute, yeah, within a 2 minute. So these are the number of tasks divided by the number of your time units. For example, hey, I want to process 100 requests 1 minute. That means our 100 requests per minute is the request per minute. Maybe 500 transactions per hour. Or 500 transaction per hour. TPH is the my throughput. The simple calculation: the number of tasks you completed divided by the time frame. whatever the time frame you divide. So whatever the outcome, that is your throughput of your systems. So generally, nowadays we are calculating throughput in the different time unit, maybe millisecond, maybe second, maybe hour, maybe day, maybe per uh, hourly basis. So these are the some whenever you are going to measure this throughput of system, we have to plot some graphs or some collect some data from your system to understand this throughput of your system. Generally, request per second. The first commonly nowadays, whatever the system we have, whatever the system we have, simple basic matrix would be your system are able to how many requests in per second. Let's say in 1 second. If you are handle 50 requests, that means your throughput is 50 RPS. Or you can handle the 500. That means your RPS is a 500. So common, simple. 1 second, how many number of requests successfully completed by the system. Or similarly, transactions. Maybe the number of transactions, maybe database transactions, different transactions is completed maybe per minute, yeah, per second. Similarly, some batch job, some scheduled jobs, that's a batch processing, bulk processing, where you can creating the jobs, job one, job two, job three. So these jobs are the number of jobs completed per hour, you can say. So in this way, you can calculate your throughput rate. So objective of that, if until you are not observing, you're not collecting matrix, might be you cannot observe your system performance. If we properly want to utilize our resources and you want to ensure that our system would be very performant, so we have to sure calculate, measure the our throughput matrix that help us our system capacity and effectiveness utilizations of my server. And these are the some techniques which help us to optimize our throughput. Whatever the business logic, whatever the algorithm, that's very good. We have to always write the very effective algorithm, effect standard quality of the coding guidelines we follow, standard practice follow, best practices follow, properly code review, properly test cases, everything. That's great. But apart from that, these are the some techniques out of box. Whatever you did, you can increase more throughput. You can optimize more throughput just with the out of box your algorithm, your code, your processing time. So you can use the load balancing. Load balancing also help us to distribute your request across the multiple resources so that all the resources are properly utilized, and that will increase the overall throughput of the my systems. Now our systems are going to serve more and more requests because our similarly caching. Caching means that's one request come, you are going to take data from the different again. Why not we can cache data? If the same request again and again, don't go process again, quickly response. So caching also store frequently access data in the cache memory that reduce the processing time and that will improve your throughput. And if your applications are also, you can use the CDN where you can utilize the increase your throughput, because CDN also is a distributed content networks. For all the static contents, you can just cache on the nearest customer user location, and that will reduce the latency and improve the throughput as well. So you can say if your latency is reduced, that means you can improve your throughput. That means you can highly utilize your system resources, and if possible you can also perform the your distributed computing. If your particular task is take a very complex, very high time, it would be possible you can break down those tasks into smaller tasks, and all the sub tasks can be processed parallelly at a different computer, different system. That will also increase the overall throughputs. Instead of only one machines are going to do heavy task time consuming task. If possible, you can break down your work to the sub component and just give to the multiple threads or multiple machines, each one process and again collect the data and combine them. So this processing like a concurrency, parallelism, multi-threading and caching, load balancing, API gateway, these are the some techniques out of box available that help us to improve our system throughputs. And the distributing component, parallel processing, batch processing, data compression, lots of technique we have it. Whatever the data you are sending to from the customer to the network, so network bandwidth are consumes. Why not possible you can compress the data, send a network, server receive them and uncompress and process them, so you can save your time. So compress data to reduce the storage and even the transmission requirement improve the throughput as well. Always possible, if possible you can do the batch processing. If batch processing means ki, your data collect every data and you start the multiple threads and do the batch processing. So batch process the multiple tasks in the batches and reduce the overall and improve the our throughput as well. Parallel processing and concurrency is the also very you can say good options you have while the system designing. If possible, this particular task or particular codes are can possible independently can be processed, different system, different threads. There is no shared communication, there is no bottleneck between that, there is no one to other are dependent to each other. So those concepts, those process, those tasks always prefer to do in the parallel processing or multi-threading. All this multi-threading, distributed computing, batch processing, data compressions, caching, CDN, these are the highly commonly used technique through which we can improve our system throughput. And lots of real applications are utilizing this concept. What are the techniques we are discussing? They are highly utilizing those techniques, maybe load balancing or caching, a distributed computing, parallel processing, batch processing, multi-threading. These are the huge system. Highly companies are using these things. Like maybe you can talk about the Amazon distributed database. Amazon distributed database also handed to design handle the high throughput by just distributing data across the multiple server and using the load balancing and caching techniques. Google Search Engine also use the distributed computing architecture where the process millions of search queries per second, just achieving and through high throughput and low latency. If you talk about a Netflix using our CDN network. Netflix uses a CDN to distribute content across the multiple servers and reduce the latency and overall improve the throughputs of the for the user perspective, right? So lots of approach, uh, but here sometimes we confuse latency and throughput. So let's talk a little bit so you can not confuse about the throughput and the latency. Both are many times as a system requirement. We talk, hey, here we have to talk throughput, here we have to talk about the latency, and overall both are the sometimes dependent, sometimes independent. If we are able to reduce the latency, that means we can increase the throughput as well as right now. So let's basic understanding. So throughputs measure the system process or completed task request within a given period of times. But here latency measure the times from a system to start request and complete it. So overall the delay between the user, let's say as a user I am sending one request and how much delay I am receiving my response. The latency with respect to directly with the customer, with the system, or with the client who are accessing my application. Throughput directly measure the overall my system performance. Hey, within a second, how much request our system are able to process, right? Generally, these are measured in the request per second, request per minute, or the transaction per second, transaction per minute. But latency always we are measured. Hey, the latency is a millisecond, microsecond, nanosecond, or highly within a second. Latency, if you're going to the minute or more minute, our customer or client is not so happy. That means we are designing a system that is the very high latency system. And these are some more points as we talk. These are talk focus on the rate overall our systems. What the capacity, what the rate? It's mostly focus on your particular independent individual task to measure. They are using generally talk about the RPS, TPS. Here generally always talk about the millisecond, microsecond, nanosecond kind of things. Hardly talk about the minute, right here. But here maybe job per day per minute we can talk. But here overall the objective of the throughput matrix is that we can ensure that our overall complete system effectiveness and effectively utilizations. And here latency mostly focus on the user experience. What customer responsiveness. Customer feel real-time response, as quick response. The latency focus on the customer user experience. What user behave when they are accessing my application? Quickly response or not? So latency focus on user experience. Overall, how our system is responsive for every user. And our throughput basically talk about the overall system effective utilizations, highly resource utilization, what the rate to process my system, right? So it's maybe you can optimize this resources using the improving lots of techniques we have available. Similarly, if you want to reduce your latency, we have a lots of option where you can reduce latency as well as. So let's example again, as we, same example discuss if our web server have received 100 requests per second. That means ki our RPS is the 100 requests per second. But latency here talk about the 0.1 second because one request is served by the zero point 0.1 second. So here latency talk more about the user. User means one, but the frequently quickly responsive my applications and the throughput overall the system from the DevOps perspective, from the infrastructure perspective, what our infrastructure highly used or effective utilizations, right? Now, if our latency going to if latency going to somehow increase, that means your throughput going to decrease. That this is a simple maths. So somehow you can say both are sometimes related to each other because finally we have to consider both. Whatever the user experience, that would be very real time and responsiveness. And along with that, as an infrastructure, as an engineering teams, as a company, software company provider, they are responsible whatever the hardware resources they are using. They are paying to the cost. So we can utilize our resources as possible as. So here, if really you want to make a kind of a high throughput, can lead the increase your latency. Sometimes your low latency can increase your simple math. Can say if your system quickly responding, that means you can your system latency you can say low latency. If you want to increasing the throughput, that means somehow you can want to decrease our latency. You're due to that. Whenever talk the system design, you can say, hey, our system would be our non-functional requirement is the low latency. So our objective should be our latency as reduce, and that will whenever our latency reduce, that means overall our system effectiveness, utilization, and throughput going to increase. Right now. So same the database transactions, whatever it is. So overall objective, if we can reduce our latency, that means we can increase our what overall throughput system. So let's say one database 100 per second we are serving. So here latency in the 0.1 second. What happens? We can utilize our database query and reduce the latency 0.05 to the caching. So now our system can increase overall throughput. Now it can handle 200 TPS per second. So in this way, we can increase our overall system utilization. So there are some trade-off we should aware about the throughput and latency. While increasing throughput may require increasing the number of resources and available system, which increase the latency as well as. Sometimes you are increase the more resources, more server, though lots of network bandwidth, lots of routing can be increased. So we have to very optimal between that. Let's you want to decreasing the latency. May you require to reduce the number of resources, but also we can decrease the throughput as well as. So we have to very balance between the throughput and latency, right? So overall, you can say whatever the techniques we have. So some techniques are very good for the throughput. This means ki I want to high throughput, low latency. I want to low latency. If these are the common techniques help us for both. If we are using the caching, so caching increase our throughput and reduce our latency as well. Similarly, load balancing also help us. They are going to increase my throughput but reduce my latency. Parallel processing also helps same. They can increase my throughput but reduce the latency. Similarly, CDN help us for both. So overall objective is our latency as reduced as low as minimum and throughput as high as more. So we have to make a balance between that and optimize systems so that our user experience is very real time responsive, and but same times whatever the hardware systems we are using, our system resources are fully utilized so that we can serve more and more requests with a limited number of requests. So similarly, we can use lots of maybe Amazon Elastic Load Balance used for the caching to optimize both throughput and latency. Similarly, Google search engine can use the parallel processing and caching to optimize the both throughput and latency. Netflix also in the both. Hey, CDN help us to use the cache and load balancing. So in many applications, these are load balancer, CDN, API gateway, many layers of the caching we are using so that we can decrease, make our latency as low, and overall system performance or throughput going to increase more and more. So these are some basic concepts we should aware. Our objective, whatever the latency of my system, whatever the latency in my system should be as low as possible. Whatever my system throughput as should be increased as high as. So objective is that we have to reduce our latency, means our system design should be go with the low latency, but at the same time our overall system efficiency utilization should be fully. That means our system throughput should be high. So objective is that request per second as more. Nowadays, talk the real time system, they are serving millions of requests per second. So that is the throughput of my system. Maybe serve the millions of requests, but what happened the customer experience, user experience, system responsiveness? That's talk about the latency. So generally, whenever you talk about the user experience, real-time responses, we have to talk our system should be low latency, right now. And if you talk about the overall our system utilizations, resources utilizations, you can talk about the request per second, transaction per second. Nowadays, generally, the message per second process, request per second process, send the message consuming per second. So many places, both terminology, throughput and latency, as a design engineer, our responsibility, we have to carefully understand whenever while discussion in the teams either talked about the throughput, so we have to understand what the meaning of throughput. They are talking about the latency, so we have to understand what the meaning of latency. Latency is the objective to improve the performance of single request. Okay, so that the user experience is the more responsive. Our system should be more quick responsiveness, but We have to ensure that overall our within a second how much request you are going to the serve. That is our throughput. That is our rate of my system. Hope this information is helpful. Thank you.